All right, so in this video, we're actually going to be looking at how to create and solve linear systems of equations. Just a few short steps to read through and make sure you're going through every time. First thing you're going to do is you're going to read your problem and you're going to define the variables. So when I mean define the variables, that means give meaning to what the problem is saying. So give meaning to those variables. I normally always use X and Y just because if I want to check myself graphically, let's say in a graphing calculator like Desmos, which I have pulled up on the side over here, it actually makes it easier to graph like standard form equations with X and Y versus if you use A or B. Now, once you've defined the variables, you're going to write the equations using the defined variables. So once you've read through the problem and you look at the details of the context of what it's saying, you're actually going to write those equations that follow the details that are given. And then finally, you're going to solve using graphing, elimination, or substitution. So we're going to go through a few of these examples together. We are going to check them graphically. We're going to do some elimination and some substitution, but the main thing that we're going to focus on is making sure that we know how to read them and create the equations themselves. All right, so given this first example, it says a farmhouse shelters 10 animals. Some are pigs and some are ducks. Altogether, there are 36 legs. How many ducks are there? So there's two main topics here in this problem, and the two main topics are going to be pigs and ducks. So when I define my variables here, I'm going to use X and Y, and I'm going to say X is the number of pigs. And again, you don't necessarily have to choose one or the other. This is kind of a you define, and once you define it, then that's the order and the variable that you have to go with. And Y is going to be the number of ducks. Now, in the problem, the pigs and ducks are described in two ways. One, we're talking about the total number of animals, okay? So we have a total number of animals, whether it's pigs or ducks, or however many of both, is 10. Then they talk about the number of legs. So we have the legs of pigs and ducks. Now, what you have to understand is that you have to know that pigs have 4 legs and ducks have 2 legs. So what we're going to do is we're going to write two equations. We're going to write the animal equation and we're going to write the legs equation. So those are the two equations that we're going for here. So if we talk about animals, now I don't know how many pigs and I don't know how many ducks there are, but I do know that there's a total of 10. So I know that the number of pigs, X, plus the number of ducks, Y, equals a total of 10 animals in that barn. That's my first equation. Now the legs equation. So we're going to make sure we go in the same order. So we're going to start with pigs because that's what we did here. So we know that pigs have 4 legs. So right here, I have 4 legs for my pig. So 4x is what we're going to be working with for legs. Now my duck has 2 legs. So I'm going to put a 2 here. So 2 legs per pig or per duck, excuse me, equals, and there is a total of 36 legs. So again, let me make sure we understand this. So for my leg equation, I have a total of 4 legs per pig, so 4x. We're going to add to that 2 legs per duck, so that's 2y, equals 36 total legs. Now, because these are both in standard form, I'm going to solve this using elimination. All right, so right here, I'm going to, look for what option is going to be best. Now, looking at this, I can either use my x's or my y's because my x here is a 1x and my y is a 1y. So I can either multiply by 4 and eliminate the x's, or I can multiply by 2 and eliminate the y's. Now, the thing that is really important in this particular problem is the fact that we're solving for ducks. So if I'm solving for ducks, then I want to make sure that I'm solving for the variable that is ducks. So we are actually going to be solving for y here. That is going to be my variable that I want to solve for. So if I want to solve for ducks, then I want to eliminate y. Or excuse me, I want to eliminate x because I'm solving for ducks. I want to eliminate pigs. So we're going to eliminate x here. So in order to eliminate x, I'm going to multiply this whole top equation by 4. All right, so this is going to be 4x. 4 times y is going to be 4y. And then 4 times 10 is going to be 40. All right, so I'm going to bring down my other equation. We did not multiply anything there. And in order to eliminate, so eliminate means we're going to get rid of, if I add 4x and 4x right here, that's going to give me 8x. That's not going to eliminate anything. So we're going to make sure that we are subtracting in this problem. Okay. So 4x minus 4x, that's going to give me 0. So that's going to cancel or eliminate. Then I have 4y minus 2y. So that's going to give me 2y. And then I have 40 minus 36. So 40 minus 36, that's going to give me 4. And then, of course, we're going to finish and solve by dividing by 2. So y is equal to 2. Now, what that means is that if I have 2 ducks, then that means that if I have a total of 10 animals, then I should have 8 pigs. Well, how can I check myself? Well, I can take these two equations and I can put them into Desmos and check them graphically. So I'm going to do x plus y equals 10. And I have 4x plus 2y equals 36. All right, so I'm finding that intersection that the two come together. And of course, I do have 8 and 2. So 8 and 2, 8 is my x, that's pigs. 2 is my y, which is ducks. So therefore, there are 2 ducks in my barn as my final answer. Okay. All right, so this next example, it says Ann and Betty together have $60. Ann has 9 more than twice Betty's amount. How much money do Ann and Betty have individually? So in looking at this example, we're obviously talking about how much money that Ann and Betty have. So I'm going to define my variables. So I'm going to say X is the amount of money that Ann has. And I'm going to say Y is the amount of money that Betty has. So it says together, okay, so together they have $60. So I don't know how much money Ann has, and I don't know how much money Betty has, but I know together they have $60. So we're going to write a total together equation. So how much Ann has, which is X, plus how much Betty has, which is Y, equals a total of $60. That's my first equation. All right, then it says Ann has 9 more than twice Betty's amount. All right, so we're doing a comparison equation here. We're comparing how much Ann has to how much Betty has. So Ann is X. Ann has 9 more dollars than twice Betty. So more than means we're going to add, and twice means we're going to multiply by 2. So Betty is Y, so twice of Betty, so 2Y, plus 9 more, so plus 9. So Ann is equal to twice of Betty plus 9. So Ann has 9 more dollars than twice of Betty. Okay, so looking at this problem, these are not in standard form. I have one equation that is solved for. So since I have one equation that is solved for, I'm going to use substitution here. This is going to be easier with substitution because one equation is solved for. I can easily substitute one equation into the other. Now, I normally will organize this in just a little chart to make it easier to know which equation is going in where. So I know that the solved equation, I have x equals 2y plus 9 needs to go into the standard form equation, which is x plus y equals 60. So right here, x equals, if it's x equals, we're going to substitute it into the x spot. So I'm going to take that x out, and I'm going to put in what x equals, which is 2y plus 9. And then, of course, the rest of it should still be the same because we're not substituting for y or changing that is equal to $60. And now we have an equation that we're going to solve for. So I'm going to combine my like terms. So 2y and y is going to give me 3y plus 9 equals 60. I'm going to subtract 9. So I have 3y equals 51. All right, I'm going to divide by 3. And I have that y equals 17. So what does that tell me? That tells me y is Betty. So Betty has $17. Well, how do I figure out how much Ann has? Well, I can use Betty's information and I can figure out Ann. So now what I'm going to do is I'm going to take that $17 that I just found for y, and I'm going to substitute that back into the original equation. So I have x equals 2, and where y is, I'm going to plug in 17 plus 9. All right, so I have 2 times 17 plus 9, and that's going to give me $43. So I now know that Ann has $43. And again, I can check this in Desmos. I can plug in my equations. That's the reason I use x and y. So x plus y equals 60. And then I have x equals 2y plus 9. Now, we're probably going to have to adjust the screen and zoom out a little bit. Okay, so we're looking for that intersection. And I have 43 and 17. So that tells me that x was Ann. We got 43 for Ann. 17 is y. That's Betty. And that's what we have for both. So Ann is $43 and Betty is $17.